name is Amjad Masad. As mentioned, I work at Facebook in the Photos team, and I'm starting to do a little bit of JavaScript infrastructure now with Facebook too. Additionally, I enjoy building web apps, and I like hacking on JavaScript, and I like hacking on open source code. Thank you all for coming out today. Thank you for having me in your lovely city. We love it so much so far. And today I want to talk about modern web development tools and workflow. I just want to make sure everyone sees the slides and can read it. Looks good? All right, cool. All right, so what do I mean by modern? So when I sat down to prepare for this talk, I thought in order to really understand where we are in terms of the evolution of web development, I decided to go back and read a little bit about the history of the web. And I'm sure a lot of you already know this, but here's sort of a quick crash course of the invention of the web. So the web was invented by Sir Tim Berners-Lee while consulting for CERN, actually very close to here. The web started actually as a notebook program. It was basically a graph implementation with links between documents. And afterwards, the web as we know it, with HTML and HTTP and all the good stuff, started in the 1990, which was based on a paper he previously wrote. Now, here's where the interesting stuff happens. Most people think that the first browser was invented in 1990, and it was invented on Sir Tim Berners-Lee's Next desktop. But the problem with that was that Next was only available, at high-end machines, so nobody really had access to that browser. And the first real cross-platform and accessible browser was a command line browser. So in order to navigate from link to link, you actually had to type a command, which I thought was really interesting. So that browser was invented in 91. But the problem, and what's really interesting here, is that command line interface technology was really something that happened in the 70s with DOS and CP/M. That's when it was popular. So what I concluded here, so this is the desktop that Sir Tim Berners-Lee invented the web on. But what I included here is that upon inception, the web was already 20 years behind. And I guess that's fine for a technology, for a new technology, but it better catch up fast. So by 1993, the web caught up to the 80s PCs and got graphical user interfaces. We're now able to render documents, render images, and render links. But to contrast that with what's happening in PC land at the time, we were starting to see advanced 3D coming to desktop. Like, if you guys remember or read maybe about Doom, Doom was a really awesome game that came out in the 90s. So I feel like this is a good reference point, sort of fast forward to 2011. 2011 was the year where we saw Doom in the web. I'm not sure if you guys remember that or you heard about that, but when I saw this, my mind was blown. I was able to play Doom on the Firefox browser. And I was really excited about it, and looking at the code for a few days, it was actually a programmer from Mozilla who figured out how to compile C into JavaScript and was able to run Doom in a web browser. But then after a few days of excitement, I sort of stepped back a little bit from that and started thinking about it. In an abstract sense, we were able to run something that was written in 20 years ago, and we're extremely excited about it. Also in 2011, I worked on a website to be able to run programming languages to learn and teach programming online. That website was called Replit, and we were able to compile and run the Ruby programming language, Lua programming language, and Python for the web. So you can go to that website and you can start typing code and run it in the browser. And a lot of companies found that useful, and that's how I got my job at Codecademy, where we were running student code. A student would come and they would learn interactively on the website. So that was my contribution to sort of implementing 90s technology in the web of 2011. Yeah, so that was to sort of drive the point that I'm trying to make here, is that the web was behind for the longest time. But something happened in the past few years, and a lot of amazing stuff happened. You know, HTML5 happened, we had the Chrome browser, and we had the browser war where they're trying to optimize for speed, and a lot of new APIs came along. So, you know, some of the stuff that just happened in a few years, we have like fast DOM manipulation. The browsers became faster and faster, and you have you know, products like Facebook that can exist on the web, and you can have a really nice interactive experience. And then you have almost near native JavaScript performance. And if you guys seen the demo, you're able to run the Unreal 3D game engine on the web. So I thought that was really cool. We also have reliable video playback. I think Netflix announced recently that they're shifting completely to HTML5 playback, which I thought that was cool. Then we have a lot of other stuff. I can go on and on about what happened the past few years, but I think we're closely bridging the gap between the web and what we can do on the PC. Now that the limit stopped being the capabilities of the browser, and it starts to be the backwardness of our tools. We're trying to build the applications of tomorrow. We're trying to build the future, but we're using the tools of yesterday. The tools and the frameworks that were built for the web was meant for a document-based platform and not for an application platform. Yet we're now trying to use it to build applications. So what's really missing from our tool set, and what can we do about it? So to build maintainable software in the web, we need powerful UI frameworks, and we need language with more advanced primitives, and we need tooling around all of that. So I sort of want to define what maintainable software is, and I know that's a really hard thing to do. A lot of people spend their entire lives and wrote many papers about how to define what maintainable software is. But I'm trying to be a little bit more scientific around this and try to come up with a framework to sort of guide me to explain what really is missing from the web and try to drive the point on how we can solve this problem. So I thought it'd be interesting to go back and look at the books that tried to discuss this problem, and one of the most famous books on this subject is The Mythical Man Month. And I sort of flipped through the book and started looking for things that talk about how to write maintainable software, and this quote standed out. The best way to attack the essence of building software is not to build it at all. So this was a section on software reuse. And throughout the book, there's the theme that goes on is about software modularity and software reuse. So after that, I sort of sat down and thought, who knows more about software modularity and software reuse? And that brought me to the Unix philosophy. I picked up a book on the art of Unix programming, and clearly Unix had a lot of success in sort of reusing software. Unix has been around for a lot of years, and right now they run our phones, they run our servers, they run almost all computing platforms on the internet. And I think they provided a nice framework to sort of think about how to build maintainable software. So for the rest of the talk, I'm going to pick up some of the principles that they had in Unix philosophy and how to build maintainable software, and try to adapt them to the web to see what's missing from the web and how we can solve the problem. So the first principle that I try to pick and sort of preface the rest of the talk with this is the rule of diversity. Distrust all claims of one true way. The idea is that there isn't a silver bullet. There's no one way to build software and everything's going to be amazing. However, I'm going to be talking about from the point of view of building software at Facebook and from my personal experience. And at least that's somewhat proven to work. Rule of modularity, another one of the Unix philosophy principles. Write simple parts connected by clean interfaces. So So although functions are really powerful as a unit of abstraction, and really can go far with them, but I think having them as the most basic and the only unit of modularity in your software is really a bit of a far stretch. JavaScript being everything global by default makes JavaScript really hell to work with. Another problem is there's no way to include code in JavaScript. The only way to include code in JavaScript is to do it in HTML. And which got me thinking, C was more superior to JavaScript, even though it's maybe 40 years older. It's a more superior language to JavaScript in terms of modularity. At least in C, you can do static, you can do extern, you can defend against unwanted globals. Another rule of clarity. Clarity is better than cleverness. This is very hard in JavaScript. In order to write any maintainable JavaScript code, you have to be incredibly verbose. So let's take an example. We have the function sum here. Sum takes var args, variable number of arguments, and sums all the arguments and return the sum. Pretty simple stuff. But in JavaScript, the first line of code that you need to write is you need to take the array prototype method slice and then call it with the arguments as the context. And that's how you get the arguments. This is a very silly thing to do. Why not just get at the arguments? And then you need to loop and then do the actual thing that you want to do. Rule of composition. Design programs to be connected to other programs. What follows from the lack of modularity in JavaScript means that programs can't really coexist. It's very easy to step on each other's foot. If any of you guys have ever built JavaScript apps with third-party, for example, ads, you've probably seen this problem firsthand, where you include some third-party software, third-party script, and it suddenly breaks your program because it replaces a built-in variable, it introduces a global, it includes a jQuery version that replaces your jQuery version. So there's a lot of room for really to mess things up here. Another problem is in JavaScript there's no built-in versioning, so you can really have a lot of conflicting versions on the page. And I think the most annoying problem is UI code is incredibly hard to compose. A lot of times when you're writing using any of the JavaScript UI frameworks, you end up wanting to compose UI widgets where you have a parent and then you have children, and you want those parents to sort of compose over those children. And so I have an example, not to pick on Backbone.js, but Backbone is a really popular UI framework. And in this example, to illustrate the problem of composing UIs, and this is a really common scenario where you have a parent view, and in that parent view, if you're not familiar with Backbone, by the way, Backbone has a main function called render, where you instantiate your UI elements and then return them to the calling function. So in this scenario, you have a parent view, and this parent view is rendering its HTML by using a template, by calling a template, and this line is really basic stuff. It's cool, but then you want to render your subview. What you end up doing is you have a function for your subview, you instantiate your subview, and then you append that subview to the parent element. And this is the first problem here, is the main idea of having templates is to separate the markup logic from the UI logic. And by having that jQuery append function here, you're coupling them again. So the promise of having templates decoupling markup from UI logic is totally debunked after you add that line of code. And another problem is this render function is fine if every time your model will change. Usually in Backbone you have a model which is an observable model, and every time that model changes, you want to change your view. And the problem is, if you want to call render every time your model changes, there's a lot of overhead here, because you're instantiating subviews, and those subviews may have also subviews, and it could be a recursive thing, and you end up every time something changes, your UI will slow to a halt, and sometimes even crash. So you end up doing things like this on model and listen to specific change events on certain fields, and then change and go in using jQuery selectors and change the values themselves. And so this also illustrates the problem where you're coupling your markup with your UI logic again. You're using selectors, that means your UI logic already know about your markup and how your UI is structured. Okay, so I don't want this to be all about the problems with the web. After I'm done with talking about the principles behind Unix philosophy and how it relates to the web, I'm going to go to talk about the solutions that we have, or at least what we try to do at Facebook. So, rule of simplicity. Design for simplicity, add complexity only where you must. And in JavaScript, you must, all the time. Now, I'm sure a lot of you web developers are, have fought with this yourselves. Browsers are very slow to upgrade, at least until recently. We still deal with IE6, which is almost 15 years old now. And that means we need to write a lot of polyfills. What's meant by polyfills is basically writing JavaScript code to implement a feature from the future. And that adds a lot of complexity to the code. If you see code where you have an F statement, if IE, then do that, if chrome, then do that, that just adds too much complexity to the code. It also takes a lot of code to keep your application state in sync with your DOM. So as we've seen in this example, every time your model change, you need to go into your DOM and update it. So you have all this glue code to sort of keep your DOM in sync with your JavaScript models. So to sort of illustrate the problem of building UI with templates, here's a template of a to-do application. We're using Mustache. We have a UL that implements the top-level element for your to-dos, and then you loop over your to-dos, and then you create a sort of a task element for each of your to-dos. That's sort of the quintessential JavaScript framework example. And then once you want to render those to-dos, it's really nice. What you call template with the to-dos, and that's kind of nice. That's what we want. The problem is later when the to-dos change, you have to go inside your template and select the to-do that corresponds to the change, to the model that changed, and then change the input. Another Unix principle is the rule of separation. Separate interfaces from engines. So what's meant by that is that you want your algorithms or engines to not know about the existence of the UI. And that decoupling creates an interesting dynamic where you can have multiple interfaces for your engines. So you can have an algorithm or an engine, and then you can have a command line interface, or you can have a web interface, or you can have a mobile interface, whatever you want. However, in web development, we're used to sort of commingling our code. We're used, whether it's UI code or not. I remember a few years ago, maybe 5-6 years ago, if you wanted a base64 algorithm for JavaScript, you would search for a jQuery plugin that does base64 conversion. What does jQuery have to do anything with base64? It's basically computation. Yet what we do, again and again, is we couple our UI code to our engines and libraries. Also, it's really, a lot of people do that where they store the state in the DOM. You call jQuery.data, and you sort of store that data in the DOM. Or sometimes you want to bootstrap the data on the page and you use data attributes, data dash, to sort of store that, or transfer that data from the server to the client. So all that creates this sort of commingling between the interface and the engine, and we can have that nice separation. Excuse me. Rule of economy. Programmer time is expensive. conserve it in preference to machine time. On the web, at least in my experience, 3 of the most consuming things I do and deal with day to day is trying to optimize DOM manipulations. We do things like when you want to keep your UI synced with your model, we do things where we batch DOM manipulations. We do things where we go in and we try to optimize the selectors. We try to use IDs instead of classes because they're faster. And we do all these optimizations, and we spend a lot of time just trying to get them right. Another thing that we do is we write a lot of boilerplate. If you want to write a class in JavaScript, you write .prototype about 100 times, at least, to just implement a class in JavaScript. And similarly, CSS is incredibly verbose. If you want to write CSS, you have all these vendor prefixes that you want to use. You want to use -mods, you want to use -webkit, you want to have fallbacks for IE. And it's just the whole thing is very verbose, and it feels like the machine can do it better than us. Why spend that human time, which is also more error prone, on things that the machine can do? Another problem that's a personal passion of mine is lack of debugging tools. I think right now with Chrome DevTools, we're getting a lot better in that area, but I think there's a lot of room for improvement. Another sort of Unix philosophy, rule of repair. When you fail noisily and as soon as possible. And I'm sure a lot of web developers here know and really dealt with the pain of how JavaScript fails silently. All the time, we have something that goes wrong and you don't get an error. And a lot of, moreover, browsers also are really lax about HTML and CSS. You can have an error, a syntax error, and it doesn't tell you anything about that HTML or CSS. It tries to fix it. And I guess that's good for the end user so they see the errors, but we should have a sort of a developer mode where it tells us, you didn't close your div tag. How many times have we spent just looking for this unclosed div tag? It's completely ridiculous. And the last one, rule of generation. And that sort of relates to what I was talking before about preserving human time. Rule of generation, basically the idea is machines are better than us in writing code, whether we like it or not. If there's a well-specified problem domain, we can write programs that write the programs for us. And that's kind of a good thing that we have in the JavaScript community now, is we have a lot of AST tools. We have AST tools like Esprima, you can parse the JavaScript, and we have tools for code generation too. And I'll talk a little bit about it later. Okay, so enough with the depressing stuff. I depressed you enough for today. Let's talk about how we can do it better. All right, how we can bring our tools to the future. ES6. How many people are familiar with ES6 here, or at least read about it? Okay, 5%. Okay, ES6 is a new version of JavaScript. It's I would say like 75% implemented in the newer browsers, but we need to wait a long time for the old browser to die in order to use it. But there are ways around it, and I'll talk more about that later. ES6 has a lot of powerful features, and it will help us. Now that we defined sort of the Unix philosophy and the principles that guide software maintainability, I'm going to use them to sort of describe how we can do better. So ES6 will help us with the modularity problem, it will help us with the principle of clarity, it will help us with the rule of economy, and it will help us with the rule of composition. Writing modular code. ES6 has powerful primitives, unlike the current version of JavaScript. So the first and obvious one is built-in modules. In the newer version of JavaScript, you can define modules. You can require modules. There's a way to require modules on the web, to require third-party modules. And you can explicitly say what you want to export from a module so you don't introduce accidental globals. And I think that's going to be a really good thing for writing modular code on the web. ES6 has also classes, so you don't have to write all that .prototype crap every time you create a JavaScript class. And now you can just use class like you do it in Java or C# or what have you. There's also the let keyword. The let keyword fixes the scope problem in JavaScript. in JavaScript, the var keyword is very misleading. It functions on a function scope. The let keyword will allow you to create it on block scope, like inside an if statement, inside a for loop, as opposed to a function scope. That will help with not creating accidental globals. So another thing that ES6 will help us with is clarity and economy. So remember that sum function I showed you a little while ago? Here's the exact same function, but in ES6 as opposed to JavaScript. Let me try and go back and find that sum function just to contrast it. So here's the sum functions from the current version of JavaScript. Notice that line to sort of get the arguments and what we can replace it with. We just replace it with this, args, and that gives us a stat. That gives us an array of arguments. And then we can call reduce of those arguments, and just implement a reduce algorithm, which is really what we want. We want to express to the language what we really want, and then let the machine do the work. Okay, so that's for ES6. I think it will help us create clear code. It will help us create readable code, and using less time for debugging. More code means more surface area for bugs. Less code means less surface area for bugs. So that's going to be a really good thing there. And I'll talk a little bit later about how you can use ES6 now as opposed to waiting 10 years in the future. So React is a JavaScript framework by Facebook, invented to solve many of the problems I talked about today. So how many people here already know about React or played with it? All right, a few. Okay, good. React will help us with the modularity problem. It will help us with the clarity, composition, simplicity, economy, and repair, all the problems that I just explained. So for those who don't know React, here's a simple React example. It's a hello world. React is made up of components that is composed of other components, and components can be low-level stuff like HTML elements, like a div or a paragraph or what have you. In this example, React, just like Backbone, has a render function that is called when your component is rendered. And in this example, hello takes a property called name and simply renders hello name. So what we're doing here is we're rendering hello to the body passing food. So it will render hello food on the body. You can also notice that we're using HTML inside of JavaScript, and I'll talk a little bit about that later. So what's special about it? So, it just looks like any other framework. The main thing is you don't need to update the DOM directly. If you go back to the example, the only place we're touching the actual DOM is when we're rendering the top level element, document.body. Otherwise, everything is done for you. You don't have to actually insert things or call .html on the element or do anything like that. So it abstracts away the DOM from you. And it also syncs it with the application state, and I'll show an example about that later. Another interesting feature is that you describe your UI declaratively. We use the XML syntax, the HTML syntax that we know and love, and you can just describe what you want your UI to look like. And the cool thing about React is that every time you change something, let's say we change that foo name, you don't have to go in and change it manually like we saw with Backbone. You don't have to use a JavaScript CSS selector to go in and change that field. What you can do is you can call render again. And I know you may be thinking now, oh, that's going to be very costly. That's going to take a lot of, the performance will be bad because every time we're calling render, we're basically blowing out the view and re-rendering a new view. But the idea here is that React can do that. You can every time render your view and not worry about what's going about the performance. And the way React does that is by using something called a virtual DOM. Every time you call the render view, you get a representation of the DOM that is not actually the DOM, because the DOM is very slow. And then React will diff the newer representation of the DOM with the older representation of the DOM from the previous run of the render function, and then come up with the smallest number of updates that we have to do to the DOM in order to get it to sync. In order to explain this better, let's take a look at a counter example. So here's a counter component. In this component, we want a simple counter where you have basically two buttons that adds one to the counter or removes one from the counter, and then we render the counter as a number. That's it. So what's happening here is we're in the render function. We're describing how our UI looks like. So in the count, in the header, we render the count, and then we attach the event handlers right on the DOM without having all that glue code to attach event handlers. So it's very declarative in the way we attach event handlers. Every time, now how user interaction happens is every time you click an add button or decrement button, increment or decrement button, what happens is we call set state. And what set state does is change the state of your component and then calls render again. And that will return a new string of the DOM, will diff it, and will only do what it needs to do in order to get your state in sync with your DOM. So in that case, every time you click add, the only thing that will change, the only thing React will do to your actual UI is we'll go and change that part. We'll go and render the state part. So if you really want to think about a component, you think about it in a way that it's declarative HTML markup, and it's a state machine. In every state machine, you have an initial state. So there's a function that is get initial state. And the initial state just takes an argument from outside, from a property, which is the initial count. And then afterwards, every time we call set state, the render will run again, and the whole thing happens. In order to really drive this home, let's look at an example from before. We saw before that the to-dos example. So imagine that we have the same example, but conceptually, when thinking about it in a React way, this whole thing will go away. We had the part before where you would reach into your DOM and update it manually. Now you only call the function template again. You re-render the whole thing again and not worry about performance. All right, React also gives you clarity and modularity. So the cool thing about working in Facebook is you don't have to worry about the small stuff or writing the code over and over again. And as we saw from the quote earlier, is the only way to write good software is to not write it at all. And so if I want to render something that you see all the time on Facebook, I just do that. That's it. I just call type ahead, and that's a React component that completely does everything for me. Also, in terms of composition, what we can do is you can have two elements coexist in the same function. So we have a photo, and we want to tag that photo. That's also a common thing you do at Facebook. So we have a photo element and a type head element. I'm sort of running out of time here, but 5 minutes. So I need to blow out. I have a lot of slides left, so I'm going to sort of move fast. Okay, so React is good with economy and repair. React will, when it fails, it will fail noisily. What will happen is React is really strict about markup errors. So if you have a problem with your markup, it will sort of shout at you. Another thing is React, you can only change state using set state. So it's easy to find out where your state change bugs are happening. To illustrate this, let's take an example. In this example, we have a to-do widget, and there's a bug in this to-do widget. The bug is you have, it says that you have 2 items left, but only have 1 item, which is to give the stock. And so let's sort of find out how we can debug this example. React, we have something that we ship with it. It's called React DevTools, which integrates with your Chrome DevTools and sort of gives you a nice debugging experience. So what we can do is we can inspect that element, and that will show us that the offending component is the to-do footer. And we can look at the properties passed into that component on the right-hand side, and it will tell us that there's 2 instead of 1. And what that gives us is really nice way and a transparent way to debug our React components. And after knowing that it's the to-do footer, I can directly go to the calling function and look at the properties being passed, and there's where I can find where the bug is manifested. So the last part is the tools. I talked a lot about the frameworks. Now I want to talk about the tools. At Facebook, we use a tool for JavaScript generation, so we can generate code called Recast. Recast operates in JavaScript syntax trees, and we use it to automatically generate code. One example of how we use it is we wanted our code to be all the new version of JavaScript, ES6. So we wrote a script to go and convert old classes, prototypes and constructors, to new classes, which uses the new class keywords. So that saves a lot of time and makes it less error prone. So here's an example of Recast. You can also use Recast to generate the new version of JavaScript, code for the new version of JavaScript. So if you want to write a sort function in the new version of JavaScript, you would basically pass in an arrow function, which basically complies to this in the current version of JavaScript. And here I have a lot of codes that I wanted to explain about how to do that, but it's very verbose. You can look it online. It's on GitHub. And so I sort of don't have time to go through that, but it's very simple to do transformation on JavaScript syntax trees and generate JavaScript code. So you can write compilers really easily. Another thing that I wrote myself and I really like using is Debug Details. It's basically a utility for debugging JavaScript. I'll give you a quick example about that. The other day I was trying to debug a problem where the window is scrolling up just magically like that after you do a certain action on Facebook. And I really wanted to know what was causing the scroll. So one way to do it is I can go and grep the entire code for window.scroll2, window.scroll-y, and body.scroll-top. This is all the ways that you can scroll in JavaScript. But instead of doing that, and it's actually going to be quite impossible to do that because at Facebook scale, those are going to be in thousands of files of JavaScript. So the solution here is set up traps. Using this library, what you can say is, I want to set up trap on all these methods, on window.scroll-by, window.scroll-to, etc. And when anything calls them, it will sort of break and tell you, hey, this is the offending code. This is what making the window scroll. Another thing that we recently released at Facebook is Flow. It's basically a live reload tool. We had to invent it because the current live reload tools on the market was not good enough for Facebook scale. Check it out online. It's at facebook.github.io/fb-flow. That's it. Thank you. Yeah. We have time for questions.
So, thank you very much, Amjad. Very interesting talk. Now we have time for a little Q&A, so we're going to pass around the mic. Please feel free to ask questions. And
yeah, I'd love to hear any questions you have.
problems, but there's one thing that I think you missed, and that's testability.
Yeah.
And that's actually, I was looking at React yesterday, and there's an issue in the tracker where someone was asking, hey, how can I unit test this stuff? And one of the developers answered, yeah, I'd love to help you, but we don't know it either.
Yeah, so actually that's true. Like, it's something we're actively working on. We're trying to get React to a state where it's really testable. The cool thing about React right now is it's designed to find bugs really easily. So, like I showed the example before, we shipped the React DevTools to make it easy to find where the problem happened. But that doesn't mean you shouldn't write tests. You absolutely should do that, and I think we're gonna have a solution for that problem soon. But you're right.
Thanks.
All right.
So you talked about ECMAScript 6.
Yeah.
Do you know if generators are included in the spec?
Yes, generators are included in the spec, and we actually have an open source project at Facebook called Regenerator, which implements generators in the current version of JavaScript. So you can actually use generators using ECMAScript 5 or even ECMAScript 3, I think. Additionally, there's a newer feature that builds on top of generator, which is the async keyword, which is pretty cool. Also, I think it's a proposal for ECMAScript 7, so I'm really excited about that one too. All right, I have another question there.
Hi.
Hey.
I just know the concept of React. Can I like separate HTML and JavaScript?
What you can do is, if you don't like using the XML syntax in your JavaScript, you can just call those as regular function. So instead of having div, what you can do is react.dom.div as opposed to just div on its own. But actually, I think one of the design decisions in React was to put the JavaScript and the HTML and the markup inside the same component. And why we think it's good is because there's already inherent coupling between the both, between UI logic and the markup. There's already inherent coupling. If you do backbone, then you always reach in using selectors, and that couples it together. So why not put them together? And we found a lot of value in just putting them together.
Thank you.
Yeah, you got it. All right. Well, thanks a lot.
We have 5 more minutes for would you mind showing the last slide? I'm personally really curious because reloading parsing F5 sucks.
Yeah.
So,
you want to talk? You want me to talk about flow?
yeah, because you skipped over
Yes.
showing it. I don't know how you guys feel, but that would make my life easier.
All right. Okay. So when I started working at Facebook 7 months ago, I really loved our JavaScript infrastructure. I liked, ECMAScript 6. I liked React. I liked all that good stuff. The only problem was every time I need to change something, I need to reload the page, do a few clicks, do a few actions to get to the flow that I'm working on. I'm working on, for example, the album upload flow. I need to upload a photo every time I test my code. I'm a really, really sloppy coder. I do a lot of typos, and I really love to sort of have that quick feedback time between writing code and doing it. So what Flow does is, unlike other live reloads programs out there, it actually hooks into V8, the VM, and patches the code. So you can have the web page without reloading, without doing anything. You can write your code in JavaScript, save it, and it will actually recompile on the spot. You don't have to do anything. And you can just have your browser right next to your editor and just write it. Also, the value of Flow over other tools is that you can use whatever editor you want in Flow. And yeah, I think it works at a scale that other tools broke at. I tried a lot of tools, and Facebook sale, they couldn't work. So yeah, I encourage you to check it out.